Hello and welcome to my fourth video on digital image processing and analysis using Microsoft Excel. My name is Dr. Peter Akonlabi, Assistant Professor of Agricultural Systems Technology at Arkansas State University College of Agriculture, Engineering and Technology. This presentation will focus on image enhancement. Image enhancement is generally applied to image data subsequent to appropriate pre-processing operations. So once you're done with the necessary pre-processing operations, such as maybe removing noise or correcting geometric distortions and so forth, then you can go ahead and do the image enhancement. The primary goal is to improve the ability to visually interpret an image by increasing the apparent distinction between features in the scene. By using image enhancement operations, we are able to better distinguish between different features in the scene to help us with interpreting the image data. We can perform the operations on a single band, let's say on a red band separately, on a green band separately, and these pretty much monochrome images. Or we can also perform the operations on individual components of a multi-image composites. The resulting image can be recorded or displayed in monochrome or in black and white. It can also be displayed in color, depending on how many color ranges are set for the image. What are some of the general types? We have point operations, which are used to modify the brightness value of each pixel in an image data independently. We also have neighborhood operations, which are used to modify the value of each pixel based on the neighboring brightness. So let's say Nextel, if let's say you are changing the operations of if you are modifying the value of let's say A2 or maybe B2, then the B2 would be would be updated or modified based on the values of A1, B1, C1, and all the other pixels around the B2. But the choice of the appropriate method is an art based on a particular application and personal preference, meaning that the particular set of operations that one would use depends on the particular application, depends on the type of images one is working with, depends on the scene, it depends on the phenomenon that is being studied, and so forth. So as the analyst becomes more familiar with the particular type of data, then one can determine which operations are best for the set of data that is being handled. What are some broad categories? We have contrast manipulation, we have spatial feature manipulation, we have multi-image manipulation, and these also under contrast manipulation we have gray level thresholding, level slicing, and contrast stretching. We would demonstrate the use of gray level thresholding, level slicing, and contrast stretching. Under spatial feature manipulation, we have spatial filtering, convolution, edge enhancement, and Fourier analysis. I'm not going to, in this video, I'm not going to explain all of these, but then I would dwell on the ones that are pertinent to our demonstrations. Under this category, we would demonstrate the edge detection at some point. We also have under multi-image manipulation, spectral ratioing, which we will touch on. We have normalized different ratios and other indices which we would look at. We have principal and canonical components. We will not demonstrate that. vegetation components, intensity, hue, and hue saturation, color, space transformation, and decorrelation, stretching. These we will not look at, but just to give that broad knowledge. And a contrast manipulation, again, we have gray threshold, gray level thresholding, level slicing. Gray level thresholding and level slicing are basically similar. Gray level thresholding would end up with data with a data that has either a 0 or a 1, or that has two values, where one would be a foreground and the other would be a background. And this is an example of such data, assuming this apple in a scene, and the left is the histogram of this apple. We have two peaks, and this is only an example. We have two peaks. One peak represents one class, another peak represents another class, and we identify a threshold value, or a point where we would separate the two classes, and so that value is used to split the data into two halves, where one set of data would be assigned one value, say 0, and the other set of data will be assigned another value, say say 1. So this is how the two-dimensional view comes to. This portion represents the dark represents the class 1, and all this, which is the background, represents class 0. So in this case, we call the thresholding also segmentation. So either thresholding or segmentation, which just splits the data into two halves. DNs are digital numbers, which is basically the pixel value. TV is a threshold value which we identify to split the data into two halves. Level slicing is similar to thresholding. Level slicing involves more than two levels. So there is a need to have different, we have multiple threshold values. So if you want to split into 3, you need two threshold values to split the data into 3. And these would be, we'll demonstrate the use of these in some application. Contrast stretching is basically used to adjust the range of brightness values in an image in order to optically utilize the full 8-bit range of display values. The maximum number of the displays is 255. We have the range starting from 0 to 255, making it 256 colors. And so in contrast stretching, if the data does not cover all the range, the entire range, the data is adjusted to be able to cover the entire range. So in that operation, we term it stretching. So the resulting image therefore heightens or increases the contrast between features of interest. Here is an example. Here we have image. We have this image. In this image, this is the red band, the histogram of the red band data. The minimum value is not 0, and the maximum value is not it's not exactly 255. So if we want to stretch this, we would apply the operation to extend or to to move the minimum value to 0, and then move that also to 255, so it's the data is stretched. And then similarly, if we do that to green, we would move the minimum value from here to 0, the maximum from this value to 255, and that will apply to the blue band as well. Here's another example. We have this starting from 0, that's the green band, but the maximum is not exactly 255, so we can stretch it to increase the contrast, and we can apply that to the blue band as well to increase the contrast. So that's about contrast stretching. Here is the equation or the formula used. dn prime is the digital number assigned to the pixel value in the output. That is a new pixel value for the location. dn is the original digital number or the original pixel value, the minimum pixel value, and then we have that divided by the maximum pixel value minus the minimum pixel value. When we multiply this by 255, we multiply this by 255, we obtain, we stretch it to the full range. And in this view, we have used features that are already in Microsoft Office to increase the contrast in in this image. The left one is the original image. The right one is in an image is the copy of the image with the contrast heightened, so we can see what the data looks like in a color image. Please do read pages 504 to 506 to get more information on this contrast stretching. Here are the operations that we can apply, and spatial feature manipulation. Again, only C I would be touching on only the C, the edge and the edge enhancement, looking at edge detection, and then once we have the data, we can also manipulate the data to obtain reflectance of the data. Reflectance would generally be the value, that's the pixel value divided by the maximum pixel value represented by the white light. So I would run through these a little bit quickly, but would show that in the demonstration. We have multi-image manipulation. These are the different operations under that spectral ratio, and we have simple ratios, and we also have normalized differential ratios. We would look at these two, and then we will not look at the rest. Ratio images are basically enhancements obtained by dividing the digital numbers or the pixel values in one spectral band by the corresponding pixel values in another band. So let's say if you are looking at maybe red band divided by green band, you would have A1 divided A1 in the red band data divided by A1 in the green band data, and then that is applied to the entire data to obtain the ratio values. The advantage here, which you will see in the demonstration, is that these are able to convey spectral color characteristics of image features, irrespective of the variations in illumination. Whether the lighting condition is great or the lighting condition is not too great, by using spectral ratioing, we are able to overcome the limitations of the illumination, and we would see that in the demonstration. One thing to note is that with a spatial ratio, each type of cover type, let's say if you have just bare ground, or if you have dry leaves, or if you have green leaves, these would show different. It will show similar ratios. So all pixels that belong to the background will show similar ratios, and even with limited lighting, that will still show the appropriate ratio values. And so that presents a great advantage in that it's able to eliminate the distortions in the image, which is imposed by let's say shadows in the image. I'll leave some of these for us to look at. I wouldn't go over some of these slides. I'll leave those for you to explore. I'll rather run through, go back to talk about come back to talk about these as necessary, but I'll leave that for your reading so that I can spend the time doing the demonstration, which would help you to better understand these materials anyway. All right. I'll jump over and look at what we are going to work on. In this presentation, we have one image to use. Here is the image. It's a soybean plant. We have the vegetation itself, and we have background. And in this image, you can also see some shadows. I mean, this would be pertinent in our discussion as we move on. So first and foremost, I would start with a gray level thresholding that I introduced. Let's begin the demonstration here by extracting our data from this image into Excel. And then once we extract the data into Excel, we can go ahead and apply the operations. Today we have just a single file to extract, so I'll select single file. The data is the folder is on the desktop. I pick that desktop. I select the folder, and I then select the image to extract the data from. So export the image data to Microsoft Excel. In this process, I'm sure by now everyone should be aware of it if you've looked at the previous videos at least. Okay, the process is complete. There is a Excel file. Okay, there we go. All right, let's go ahead and change this to red, green, and blue. Okay. I'll delete this worksheet. Okay, so I have the red, green, and blue, and then you see data which you should be familiar with by this time. All right, first and foremost, I'm going to visualize this data. Go to Insert, Charts, All Charts, Surface Charts, Contour, and there is the data. Okay, double click the vertical axis, series in reverse order, to bring our data into the right orientation. Okay, now we have 1, 2, 3, 4, 5 different colors representing the different ranges in the scene. Let's go ahead and change the values to better visualize the image. This is just a red band. Okay, here is the, let's see, this should be dark green. Okay, then next let's change this one to a little lighter green. Then change this one to another shade of green. Change this to a lighter shade of green again, and then we'll change this to brown, which represents the soil. So this is what the data look like. This is what it looks like. This is red band. Let's see. I'll just make it R. Okay. I'll do a similar thing in the green band. Insert, Charts, All Charts, Surface, Contour. Okay. Double click. Let's change the orientation, reverse, series in reverse order. Okay, let's see. It's probably going to be the same type of data. Let's see what we have here. Okay, a little lighter green. Then this. That. No. Yes. And let's make this one back to brown. So we can see that we have to change this a little bit because the range of colors are not the same, because this is a different band. Let's change this to the brown and change this to maybe darker. It's actually orange, but darker orange. So this is how the data look like. This is green. Let's make it G. And then I'm gonna go ahead and create a new, open a new PowerPoint. Okay, and then copy the red and green so that we can look at them side by side. First, I'm going to copy the original image, color image, and paste it there. All right, reduce so we can compare side by side. Here's red, copy, paste this here, and this is red. Okay, we can bring this down slightly, maybe reduce it a little bit so that it's side by side. We can all right. So this is the original image, this is red band, and then we have green band. Let's paste this one here. Oh, come on. All right, so here is our green band. And I'm going to leave this one. I'm going to come back and explain that, talk about it. Let's do the spectral, not the spectral ratio, in the gray level thresholding. Remember to apply any manipulation or to apply any operation on the image data, we cannot use the red, green, and blue directly. We have to create a new worksheet, which will become our output worksheet, and then make reference to the red, green, and blue data to create the new data set. So I'm going to have to right click this and create a copy, move or copy, move to end, create a copy. And then I would call this, double click, I would call this R underscore, or just R trash. Just R trash. So R trash means I'm going to do the thresholding based on the red value. Before I apply the thresholding, I want us to look at the red band data, the histogram of the red band data. Remember how we did a histogram? Let's make this red pixels, R pixel. Okay, we have 0, 1, 2, 3, and drag this to 255. 255. There we go. 255. Okay. Data. Oh, we don't have our data analysis toolbox. Our data analysis toolbar. Quickly add this to it. All right, there we go. Data analysis. Look for histogram. Okay. Input range would be my R. I'm still playing with the R. The bin range would be I can select the entire column here. Both of them have labels. The output range, I want that to be G1, and then I want to see a chart output. Okay. What do we have here? Just wait for it. Okay, so here is a histogram. Let me delete this, and I'm not going to copy this. I just want us to see it. So basically we can see a small peak here, another peak, and then there is another peak. If we consider the image making up of just green vegetation and background, and this is these dark spots are shadows. We probably would have this peak to be the shadow, and this peak to be I guess I have to look at our data. Okay, so on the lower side we have, okay, so this peak, there will be a shadow, green, and then yes, so this peak would be the shadow. This other peak would be the green vegetation, and this peak would be the background, which is the soil. Okay, so if we want to split this into two, we have the threshold value will be around here, so maybe about 150, 160, or 170, anywhere around here. We'll decide to choose something to split the data set. But remember, when we split, we have the shadow showing up, so we'll see how that would appear in our threshold value. So let's go ahead and say we used 160 to be our threshold value. This is what we would do. This is our output data. We'll change the equation here. This would be equal to, I'm going to work in the formula bar. So equal to, we want to make a decision if the data from R, okay, click on R. So if R A1, if the value is less than or equal to, we said 160, 160, look at the input required. We have the logical test, which is what we have entered, and then we'll have a value if that logical test is true or if it's met, and a value if that logical test is not met. So if A1, R A1 is less or equal to 160, we want the value to be 0, representing the background. Otherwise, we want the value to be 1, representing foreground. So let's go ahead and enter this, and then copy, Control C to copy. We want to apply this to the entire range data. Okay. Okay, so the data is basically split into two. We still have 5 colors showing. Let's change that to show only 2 colors. And so what do we do? Select this, go to design, change our type, select 3D surface, okay. and that is our data. We have foreground and background. Let's make sure that Excel is not going to change it back to what we didn't want. And what you want to do is that you want to select a maximum value, which would also include the foreground value. So you don't want the maximum value to be the same as the foreground value. We have the minimum class is 0, maximum class is 1. But I would explain that a little bit later. But for now, let's keep it the way it is. We have 0. Let's tell Excel we want to keep it at 0, and maximum, let's keep it at 1. Let's add a 0 so it remains fixed. And the major value, let's make it let's leave it at 0.5 for now. Okay, so we have only 2 values showing. Change chart type back to contour, and there we go. Now we can change the colors. Right click this. We want that to be background. We can choose this. Oh, come on, sorry. Make sure that the appropriate color has been selected. I think we made a mistake here. Alright, we're gonna have to go back and change that. So instead of making it if it's less than 160, that was supposed to be 1. That was supposed to be the background, because when we look at this, this is rather less than 160 is rather the background. More than 160 is rather the less than 160 is the foreground. That's the vegetation. More than 100, greater than 160 is the background. So let's correct that. This is supposed to be, if it's less than 160, make that 1. If it's not less than, it's greater than 160, make that 1 0, so that our colors would match. Copy. All right, so the other way, yes. So we have our background, and then we have our foreground. Let's copy this and send it to our PowerPoint here. Here we have, this is red trash, which is our threshold. And I'm not going to go ahead and do one for green, but I just want us to take a look at this. Do some comparison over here. If you look at the image clearly, we realize that we have green vegetation, we have soil, and then we have shadows. If you look critically, at the red band data, you realize that shadows are showing here. Shadows are showing here in the image, and when we picked our threshold value and applied the thresholding or segmentation, we realize that a lot of the values or the pixels here belong to the soil, but because of the the shadows, they are appearing they are coming along with the green vegetation. And this is a problem when you use the raw data, if there is illumination defects like shadows, they would create problems. So there isn't a very good distinction when you look at the image up here. There isn't a very good distinction between the soil and the vegetation, especially where you have the shadows showing up. And when you compare the red band to the green band data, you realize that there is a different thing. It's a different type of data altogether, and none of these between red and green, none of them is a true reflection of the actual scene. So in order to correct this, I'm going to jump ahead and apply spectral ratioing to the data, and then after that I would do the thresholding, and I would compare that to the original data. So to do the spectral ratioing, I'm going to go ahead and do a simple ratio between red and green. So it's going to be red pixel values divided by green pixel values. Then after that, I would apply the correction. I would apply the thresholding, and then we can compare. Okay. Let's create, copy this red band data, move or copy, create a copy and place it at the end. Now let's change the name to red underscore green, which represents red over green. So in this output data, all we do is in the A1 you'd enter equal to, and we said red band, so A1 in the red divided by A1 in green. Now I want to us to watch this. There is something showing up here in our formula. You can see once I clicked on A1 in green, dollar signs were added to that part of the formula. What a dollar sign would do is that it will fix the denominator at A1 when we apply it to the rest of the data. But that's not what we want to do. We want the ratios to be corresponding. So A1 would have to correspond, A1 in red will have to correspond to A1 in green, A2 will have to correspond to A2, and so forth. So if you see this happen, delete that dollar sign so that it's just R1, A1, and so forth. Let's enter and see. So this is what the data look like now. Let's create a copy. Let's copy this and apply it to the rest of the data. Control C, Control and Shift down, left arrow, no, right arrow, and then down arrow. Enter to apply. And that's our new data. Let's go ahead and change the appearance here. Let's go to design, change chart type, 3D surface, then OK. We want to revert the number of colors to 5 colors rather than the 3 that Excel has automatically set. Select the vertical axis, click on axis options, expand the axis options. We want the minimum to be 0. OK, leave the minimum at 0. The maximum is 1.5. OK, leave it at 1.5. Add a 0, leave it at 1.5. We want this to be 5 colors instead of 3 colors. Let's make this instead of 0.5, we make it 0.3. So 1.5 divided by 0.3 will give us 5 colors instead of 3 colors. So 0.3, enter, and we have 3 colors showing here. Let's change chart type back to 2-dimensional, the contour chart. Okay, now we can clearly distinguish between this and that. Let's see which one is this one. Is this going to be our brown? Let's see what we have here. Just changing the color just to be sure which one we are dealing with. Okay, so yes, this is going to be our brown. Let's stick to this value. I'm just trying to see the colors well so that I can better represent that. And this must be, this green must be belong to the leaves. Alright, you're gonna have to copy this one and add it to our view here. Alright. Yeah. So this is red on green. Okay, now let's do the comparison. All right, now if you compare if you compare the red, green, and then red on green, and you look at the original image, you would realize that this shows in the red on green ratio data, there is a better distinction between the leaves and the ground. For instance, in between the leaves where you have the ground showing, the ratio data shows that very clearly, whereas the raw red data and green data did not show that. So the red on green is an enhancement or an enhanced data based on the red on green ratio is an enhanced data based on red and green band. And we can go back and look at the histogram to give us a better idea as to what the separation, the critical value or the threshold value would be. I mean, from just looking at this, it's going to be about maybe about 1. So the threshold value is going to be about 1, but we want to visualize that in the histogram. So let's go back to UC and right click on E and add insert one column. We want to add one more data here. Let's copy the red, click on the heading, copy this, and let's put that in D. Change that to red over green. Okay, and let's apply it here. This is equal to red over green. Okay, that's our data. Copy it, apply it to the rest of the data, and now let's create a histogram. Okay, let's create another histogram for the red on green data. To do that, let's quickly check what the minimum and maximum values are. All right, let's do a quick check here. Minimum, maximum. Okay, this is equal to minimum. Let's select all this, Control Shift, enter. So that's the minimum value, 0.3 something. Was the maximum value? Equal to maximum. Yes. Control and Shift down arrow. Okay. So here is our minimum value, 0.3. Our maximum value is 1.3. So let's round it to 1.4. So if we want to find, let's say we want 100 points. We want 100 points histogram based on 100 points. Let's see what this would be. This would be equal to the range, which would be the maximum value minus the minimum value. That's the range. We want to divide this into 100 points. So this divided by 100, it means that we would have each unit would be, each unit would be about 0.01. So 0.011. Let's make it 0.01. So this is our pixel. So 0.01. Let's forget about all this. Let's enter it here. This is R on G or RG pixel. Let's just make it RG pixel. And this will be 0.01, 0.01, 0.02, and then let's copy that until we get 1.4. all right, 1.4. okay, 1.4. all right, now if we can delete this, we don't need it anymore. We only use that to see what our divisions would be. So here we have this is the RG pixel, just like we had the R pixel here. Let's now apply the histogram, data analysis, histogram. Input range is not a column A anymore. Now we have it column D. Input range is column D. Bin range is now my column L. Okay, each of these have labels. The output range, I want that to be N1. I'm looking for a chart. Click OK. It's taking a lot of time. Let's give it a couple of minutes. It's done. Okay, so there is our histogram. Let's delete this and change this to be 4,000. I think it's supposed to be about 4,000. Yeah, make it 4,000 and give us a better view of it. I'm going to have to copy this and take it. Oh, do we have it in here? Oh no, we don't have it. So I'm going to compare this to that one. All right. So from our image here, we see that the R on G, the lower values represent the leaves of vegetation, and the upper values represent the background. Now let's look at where the value, the critical value or the threshold value could be. So this peak here is again, the peak represents this range, the lower peak, which is the leaves. So this is this peak represents our leaves, and then this peak represents the soil. Okay, remember that in this ratio, the effect of the shadows have been minimized or have been removed. So we pretty much have just the vegetation and the soil, the bare ground. So we can find a threshold value around here. We can choose maybe 1, maybe it's between 0.9 and 1.02. Let's say we pick a threshold value to be 1. Okay, so now we know what our threshold value is. We have confirmed that to be 1. let's create the threshold value based on the ratio R over on G. To do that, let's create a copy of this, or maybe we can, okay, let's rather create a copy of this. Move a copy to the end, create a copy. Okay, there it is. Let's make it RG trash. Delete this RG trash, and let's change the formula here. This is if, okay, let's start it all over. This is equal to if A1 here, and let's remove the dollar signs. They are showing up again. If A1 here is less than or equal to the threshold value, which we have identified to be 1, then we want that to be 1. That is our foreground. And then if it's rather greater than our threshold value, we want that to be 0. That is our background. And then we enter. Okay. Now let's copy that and Control Shift down, left, Control Shift down, Control Shift down, right, Control Shift down, down. Okay, so here is our updated. This is R G threshold. Okay, let's copy that and paste it here. So now we have threshold value, thresholding based on RG. Let's look at it in slide show and compare. If you look at it closely, you would realize that in this separation, in this thresholding, which is the thresholding based on the ratio, there is a better distinction between the background and the foreground. So you can tell that if you look at the original color image, you can see all the background showing among the leaves, which we can't make that distinction very clearly in the red and green band, but we can make that clearly in the RG data. This is something that is important. The R on G ratio data is a better enhancement, or is an enhancement of the R data alone or the G data alone. And because due to the time, I think this presentation, I'm going to stop over here. We have looked at red band data separately. We have looked at green band data separately. We tried to do thresholding, that is splitting the data into two classes, one representing a foreground, one representing a background, and we saw that by using just the raw data, such as from the red band, we don't get a very good distinction or between the features, that is the background and vegetation. However, when we convert the raw data into a ratio data of red on green, we improve the data, we enhance the data. And so when we do thresholding, we can see all the ground showing up in here. We can see that it's appearing. It's clearly identified. It's clearly distinguishable in the R on G data, and that is an enhanced output compared to the red and green alone. All right, I would stop here, and then our next video I would continue with the image enhancement. I'll pick it up from here. I'll build on from where we have reached today. All right, thank you very much, and hope to catch you up in the next video. Thank you.